Hello, welcome to the system programming series. This subject is taught in GTU, Gujarat Technological University, and the subject code is 2150708. It is taught in fifth semester BE course, Bachelor of Engineering course. So, I will talk about all the things about system programming. So, what are the agenda for this particular video? Uh, I will go with the introduction. Uh, in the introduction, the major point I will focus is what is system, what is a system. Second point I will discuss is how system works. How system works. Third point I want to discuss is role of operating system. Then what I want to discuss is challenges before before going to the challenge part. I want to discuss need of system software, and then I want to discuss is challenges before system software. So this is my agenda for this particular video. Okay, so let's just start with the definition of a system. So basically, in this course, system implies for the computer system. Okay, so we all are familiar with what is a computer. It is some kind of computational device, a programmable computational device. So we can write programs, or we can program the computer for doing various tasks. So the system here means the computer system. Now the computer system is basically a digital system. So what is the meaning of this line? The computer system is a digital system means the computer only works on binaries, that is 0 or 1. So the computer system do not understand any other things, it only understands 0, 1, and that is why it is called a digital system. Now let's analyze how this system works, how the computer system works basically. So the computer system is having one component called CPU. It stands for Central Processing Unit. Now what is this Central Processing Unit? We can say it is a brain of the system. So the computer system is performing all the calculations, all the tasks assigned to the system. Now the task, when we talk about the task stands for some kind of program. Okay, so whenever we assign some program to the computer system, then the CPU execute that particular program. Okay, so the program and associated data. A program is not only the instructions, program is also some associated data which is required to perform the computation. Let us say I want to add 2 plus 5. Okay, it's a very simple instruction, it's a very simple task. I want to add two things, 2 and 5. So the instruction here is add. I want to add, but the associated data, add is not the complete thing. We actually want to add two things, 2 and 5. So associated data is 2 and 5. These are data, and this is what the instruction. So I personally define program like this. A program is set of instruction and associated data to achieve some goal. Here goal means some computation. Okay, so this is what the program is: a set of instruction and some data which is required to do some computation, right? So that is a program. So when we talk about the program, it is associated with the data and the instruction. Now each instruction is executed by this CPU, but the question is how the CPU will get the instruction. The CPU is getting the instruction from a unit called memory. Okay, so memory is basically the RAM, the random access memory, which is normally called the primary memory also. Okay, so all the instructions, all the associated data are stored here in the memory. So what the memory is containing? The memory is containing all instructions as well as associated data. So these two things are contained in the main memory or the primary memory, and the CPU is fetching all the instructions from this memory, all the data from this memory, and then here we can say fetch all the instructions from the memory, all the data from the main memory or from RAM, and then computes. After computing everything, there may be some output. So the output is sent to some output device. Now the output device may be a monitor, maybe a file, maybe a kind of keyboard, network. So these may be the output device. Here the output can be sent. So if there is an output, that will be sent to the output device. Now sometimes the CPU requires some extra information from the user. Okay, so in that case the user can submit the extra information via input device, right? So what are the input device available? The input device may be your keyboard, input device may be your mouse, input device may maybe your file, possibly input device may be the network also. So this is how the entire system works. Simple. Whatever instruction we have in the memory, the CPU fetch it out, execute each and every instruction, and if there is an output, then the output is sent to the output device. If the CPU requires some intervention from the external user, then the user should give the input through this input device to the CPU, and then CPU execute each and everything and computes the result. So that is how the system works. Now there are 2 or 3 questions comes in mind, and the first important question is, who is going to load the instruction, the program, into the main memory? So the question is, who will store instruction and data into RAM? So that is the question. The very simple answer is, why not the programmer? The programmer is writing the program, so programmer can load all the instruction to the RAM. But practically it is not feasible. Practically it is not the solution. The reason is, computer is meant for end user. So every time associated with every end user, there should not be a programmer, right? So if I am producing the computer to the end user, then end user I am expecting is not a programmer, right? So the end user, how end user will use the program, because end user do not know how to load instructions into the RAM. So that is not possible that every time the programmer comes with the end user and load all the instructions, right? So this is not a feasible solution. This is not feasible. Now, what should be the another answer? The answer is the OS. The OS stands for the operating system. System do this task to load all instructions into RAM, or the part of the operating system is loading all the instructions into the RAM. Not the entire operating system is designed for that purpose, but obviously the one part of the operating system is doing that task. So here the role of operating system is very important. So let's first define what is an operating system. Before defining operating system, I want to define an software. It is nothing but a set of instruction and data. So sometimes the software is anonymous, or is a synonym form of program also. But normally there is a practical difference between a program and a software. Normally the software is a very large program. Normally program is considered as a small size thing. So that's okay, but practically software and programs are almost same. So software is nothing but a set of instructions, and those instructions should be executed by the CPU, right? So what is a software, and why this software is required? See, the end user, if you consider this is an end user, is using the operating this computer system. Right? So end user must use this computer system. But the question is, the end user is not a technical person, is not a programmer, or is not a computer expert. So for the end user, we design software. Now through the software, the operating system is the end user is interacting with the computer system. So if the end user want to calculate something, then end user must not write the program, must not load all the instruction into the RAM. Rather, it is interacting with the computer system through some software. The software is designed, and through that designed software, the end user is communicating with the computer system. So that is the purpose of having the software. Now, software is designed for two basic purposes. One, which is near to end user, means the end user uses that software. Those are called application software. But there is another kind of software. This is also a software, but directly the end user is not interacting with this kind of software. But this kind of software is giving a platform to run application software. That is called system software. We can say, like, if you want to take an example, we have Microsoft Word, we have, say, a kind of music player. All those this kind of software is used by the end user, right? But ultimately, this software is interacting with the system and get the result, right? But there are other softwares which are called system software, and system software is not directly used by the end user. End user is not directly using it. Rather, end user is using application software, and application software is interacting with the system software, and system software interact with the underlying hardware. So, and whatever be the computation done on the hardware level, the system software get it from the hardware and send it to the application software, right? So what are the examples of system software? Operating system, compiler, linker, loader, assembler. So we will, there are other system software also. So this is basically the broad categories of softwares, and we are basically interested in this part, system software. So now OS, we are trying to define OS. So OS is a software which basically manages all hardwares. So if we require to manage hardwares, then we require an operating system. Operating system is basically preloaded into the RAM, and then it controls every hardware, right? Hardware also includes CPU, also includes RAM, also includes input output systems, both. Everything is controlled by this operating system, right? Now what are the role of operating system? Obviously, controlling the hardware, that is one part, but executing other program, not executing, or I am able to define it like scheduling other program for execution. Okay, that is one task. Managing and accounting other hardwares. So managing is one task, and also there is an accounting purpose, like if we have, suppose, 1 GB RAM or 1 MB RAM, then how much RAM is currently used and how much RAM is free. So that accounting part is also taken care by the operating system. Okay. Providing security, okay. So these are the part of operating system. The operating system is taking care of all those things. Now, so the role of operating system is very clear. When we have a CPU, when we have a computer system, then we have all the hardwares, we have CPU, we have RAM, we have input output devices, but all those devices are controlled by OS. And OS is also, there is one important feature of the OS. The OS is providing a platform for for application software. And through the application software, the user is using the computer system. So on the top of this, we have application software through which the end user is interacting to the computer system. End user is using application software. The application software is communicating with the operating system. Application software is communicating with the operating system. Operating system communicate with the hardwares, all the CPUs, RAMs, and etc. Then whatever be the computation done by the hardware is returned to the OS. The OS is returning back to the application software. And application software obviously send that output to the end user. So this is how the hierarchy of softwares works. Now we have discussed various importance of the operating system, what the operating system is doing, but there are various things which is a part of the operating system, but operating system is not doing that. One task, obviously I mentioned, providing platform for application software. And what is the end goal of having the computer system? End goal of the computer system is it should be accessible by the end user, right? That is the ultimate goal. Now, if the end user is a programmer, it's okay because a programmer can understand how the computer system works. But if end user is a layman, it cannot understand how the computer system works. So, end user is communicating with the application software, and that is why I can rephrase the thing like the ultimate goal of computer system is to design the application software, because the end user can communicate to the computer system via application software. So, who is providing the platform for designing the application software? It is the OS who is providing the platform for application software. So, the meaning of this statement is we require an application software. Every time we require an application software, that is our requirement. Because if we want to use computer system, that is the requirement. Now, application software is designed on a particular OS. Operating system is providing a platform for designing the application software. Now, when we start with the designing of application software, we can design it using various language. So language is used to design application, or I can say it's the software, simply software. It may be the operating system, it may be the application software, but all the things are designed on some particular language. So the question is, which language I should use to design the application software, because that is our the end goal. Now, if we realize CPU or the computer, if we realize that the computer system is a digital system, as I already told this point, digital system. So it can understand only 0 and 1. So why not we start designing the software on this 0-1 scale, 0-1 pattern. That is the simplistic one, right? Because the computer system is easily understanding this 0-1, right? So if we start writing code in 0-1, then it is called machine level language. Okay, so what is a machine level language? It is written in zeros and ones, right? So this kind of language is already designed when the computer system evolved, right? Now, what are the difficulty? Why not we are going for this machine level language? Let's analyze this with an example. Let us suppose the instruction is also written in form of 0-1 and data is also written in 0-1, right? That is the point, because computer system cannot understand other than 0-1, so everything should be written in 0-1. So that is one important point. Instructions and data is or are written in 0 and 1. Fine. So whenever we are dealing with the machine level language, everything is written in form of 0 and 1. And machine level language is the only language which is understandable by the computer system. Computer system cannot understand anything else. But let us suppose, let us see why we are not using this language. There are various reasons, and one obvious important reason is, let us say there is an instruction 11011101, and assume that this instruction is for add. Okay, and 101 1101. This instruction is for subtract. So what will happen here, if we analyze these two instructions, then these two instructions is vary only at this point. If we swap out these two numbers, then we are getting this one, right? Now in a large size program, if there is a small mistake like this kind of exchange, then it is very hard to find where we have made that mistake, right? And that is why the machine level program is very buggy. What do you mean by bug? It is a logical error. So there are a lot of logical errors possible in machine level language, and that is why it is very hard to debug. What do you mean by debug? To find out the logical error. So it is very hard to find out the logical error in machine level language. Not in a single instruction, but if I talk about a large scale program, then it is very buggy. That is the problem with this particular language. But yes, this particular language is very fast. If you write the program in this language, then it will be executed very fast, because we can directly execute this program, this kind of program into the CPU, into the computer system, because computer system easily understand what is written in 0 and 1. Now, so for a very big or moderate size of program, machine level program is not fit. So we have a machine level program, machine level language, that is not practically used to write large size program or moderate size program. So then what we will use? So what people think and why people think about its solution? First of all, it is very buggy. That's very clear. The second point is, programs are written by the human beings, right? So programs are written by the human. That is the point. And human are not comfortable with binaries. That is why this is another reason why we are not using this machine level language directly. So what is the solution? The solution is obviously not to use machine level language, but we cannot escape machine level language because the computer system understands only this. So what the solution? The solution is we design some other language which is written in a kind of high level language, kind of natural language, kind of the language which is understandable by the human being. So we are going to design another kind of language which is called assembly level language. Now assembly level language, here we are not using the 0, 1, here we are using 0 and 1. Here we are not using the 0, 1, but rather we are using some kind of short forms to represent one command. So as we have discussed, Suppose this is an instruction for 11011101. This is for add, and 10111101. This is for subtract. Then we are not going to use this form, but rather we have given a particular name for this instruction. And if the name is given like add, then we are not using this, rather we are using this. Similarly, this is used for subtraction, addition, subtraction. And if the name is given to this particular command is SUB, then we are not using 10111101, rather we are using SUB. These things are basically called mnemonics. So in assembly level language, we are not using 01, rather we are using mnemonic, right? And mnemonics are basically the short forms of the command, in some high level language, in some natural language. Here we are using English as a natural language, mostly. But again, this language is a little complex. Okay, before going to the solution of this language and problem of this language, what we do, we have written everything in mnemonics, right? We have used add, subtract, multiply, all the short forms, and okay, everything is written in form of short forms, but that short forms cannot be understood by the computer system. So we require some mechanism to convert that mnemonics, convert that short forms into the machine forms. So here some mechanism is required to convert assembly level language to machine level language. Okay, because the computer system only understands the machine level language, and if we are writing program in assembly level language, it is completely a requirement that this assembly level language should be converted into the machine level language. And who is going to convert this conversion, or doing this conversion? It is called assembler. The assembler is converting assembly level language to the machine level language. Okay, but again, the the assembly level language is still not good for large scale development. It is quite useful when we are using moderate size software, moderate size program, but for the large and very large program, assembly level language is not fit. The reason is we are using the mnemonics. Mnemonics are nothing but the short forms, and many times the short forms are still confusing. Like if we talk about the mul for multiplication and or we can say add and add r. There are two commands, add and add r. This add possibly can add two instructions from the memory. Add r can add two numbers on the registers. There might be various versions of different program, different command. So remembering all those versions are still not feasible, right? So that is what the problem with this assembly level language. So what is the solution? We should avoid assembly level language if we are writing everything in we are writing a very large or large scale software. So what we require is to another kind of language. This is basically called which is basically called high level language. Now, high level language are basically written in natural language, obviously in a particular form, but it is basically written in the natural language like English. So, this high level language must be converted into the machine level language, because if we are writing in everything in the high level language, that cannot be understood by the machine. Machine must understand only the machine level language. So there are two ways. Either we go and convert it directly into the machine level language. That might be one solution. Another solution is high level language should be converted into the assembly level language, and then the assembly level language should be converted into the machine level language. We in most of the cases we follow this path. High level language is converted into the assembly level language, assembly level language is converted into the machine level language. Reason I will discuss in the other videos. But who will convert this is called compiler. So compiler will convert whatever you have written in the high level form to the assembly level language, and then the assembler will convert everything into the machine level language. So this is what the problem with the machine level language, and this is what the solution. We ultimately come to the high level language where the programmer is more confident. Programmer is it is easy for the programmer to understand this high level language, but we have different tools which convert this, we do this conversion basically, compiler and the assemblers, right? So this is what the challenge is. This is how basically the application software is designed. If you are designing the application software, we write everything in the high level form, that will be converted into the assembly level form, and then the assembly level form is further converted into the machine level form. So in case of system programming, we are trying to study how the compiler is designed, how the assembler is designed, and there are other system level softwares like linker and loader, what are their roles, and how they are designed is the basic part of this subject. So I can define system software like this. System software are those software, the software which works on behalf of computer system and make the system useful. Now, system software basically it works on behalf of the system. Why it is working? How it is working on behalf of the system? It is basically helping the programmer to design application software through which the end user is actually accessing the computer system, right? So in that way it is working on behalf of the operating system, on behalf of the computer system, and it is because of these softwares we are able to design the application software. That is why this software, these kind of software makes the operating system useful. If we don't have any kind of system software, then the computer system is not very useful, right? So I can summarize the whole thing in one sentence. computer system cannot be used without application software. And application software cannot be designed without system software. So that is the main point. If you want to use the computer system, the application software is the ultimate solution for obviously for the end user. And application software cannot be designed without the help of system software. So system software is required for maintaining the system also and designing the application software also, right? So that is what the summary of this particular introductory chapter. Later on, I will go in deep and tell you how we can design system software. But what is the important role here? And one line I want to add, that is after this point, I want to add any software requires some language to develop. So if you want to develop any kind of software, the language is required. So in the next and other subsequent video, our main focus is language. If we are designing the language, then what are the tools required for designing the languages, for passing the languages, means converting the languages slowly and steadily towards the system. So that is what will be discussed in next and subsequent video. For this video, it is this summary. Thank you for watching this video.